All right, so continuing our conversation on factoring, we're going to take a look at some more trinomials with some different leading coefficients, and we're even going to talk about factoring some special cases, one special case in particular. If we can remember the trick, and if this fits the special case, then it might make our lives a little bit easier. So, first things first, let's do a little bit of reviewing of multiplying two binomials, right? These guys. We know that we're supposed to double distribute. We also know there's a trick to this if we remember the trick, but I want to double distribute just to kind of show what's going on. So we go here and here. So x times x is x squared. X times negative 3 is negative 3x. Then we go here. 3 times x is 3x. 3 times negative 3 is negative 9. Now, before we get to the trick, if we just double distribute, our two middle terms, or if you want to, if we want to talk about it and how we factor, our smiles are going to add to 0. Negative 3 plus 3 is 0. So it means that those terms are going to add out to 0 and be gone, and we just get x squared minus 9. Well, that gets us to our trick, where if it's a sum and difference product, we talked about this before, a sum and difference product, where our binomials are exactly the same except for one's addition and one's subtraction, then we can just square the first term, square the second term, and stick a minus sign between them, and that's it. That's how you multiply those two binomials together. So if we use the trick on the second one, we square the first term, square the second term, and slap a minus sign between them. So, and we know that it's because the smiles add to 0. Now, we want to be able to take this and factor it back into this, right? And we're going to use sort of just a reverse method, right? But so some things you need to notice. One, both times we multiplied this sum and difference product, we got two terms and two terms only. Instead of three, instead of a trinomial, we got a binomial. That's because the middle term adds to 0. So what that tells us is that if you've got a binomial and it's a difference, because both times our constants were negative, if you have a difference of two things, and those things are what are called perfect squares, in other words, I can square root them, then we can factor down pretty quickly. Okay? So we want to be able to factor what's called the difference of two squares, and there's something called a perfect square trinomial. We're not going to worry about that too much today. Okay? So, review. If you have a sum and difference product, multiplying those two binomials is quick. You just square the first term, square the second term, and slap a minus sign between them. Vice versa, if you go backwards, if you start with this binomial and you want to factor it, then we use this trick, right? So the trick only works as long as you have a difference of two squares. So we've got to be two terms, a binomial. It's got to be the difference, which is subtraction, and you've got to have two perfect squares. Now, what do I mean by perfect squares? Well, those numbers like 4, 16, 25, 9, 81. These are all numbers that you can square root and get a whole number. And additionally, perfect squares, as far as variables go, are any variables that have an even exponent, right? The square root of x squared is x. The square root of x to the fourth is x squared, right? You're looking for something that if you multiply it by itself will give you what's inside the square root. X times x is x squared. X squared times x squared is x to the fourth. So the square root of x to the fourth is x squared. You just divide the exponent in half. Okay? But anyway, if you have a difference of two squares, then you just create your two parentheses, you square root the first term, square root the second term, and do plus or minus in your parentheses, and you're done. Okay? For example, this guy right here. But you have to check the requirements first. two terms, a binomial that you want to try to factor. This is sort of your trigger to make sure that you check your requirements. So there's two terms, 1, 2. It is a difference, and if I square root these guys, I can do so easily. I can do so and get whole numbers, or I can just square root them, right? So this is a difference of two squares. So all you do is you create your parentheses, and of course we're supposed to be looking for a greatest common factor first, which these guys don't have. We need to talk about that. But anyway, create your parentheses. You square root the first guy and get n. Square root the second guy and get 6. Then you go plus or minus, and you're done. That's it. So the trick is pretty easy as long as you keep in mind when you can use it. So here, binomial. This is your red flag to say, hey, wait a minute, I might be able to use this difference of two squares trick. Two terms, 1, 2. You can even square root both of them, but the problem is it's not a difference, it's a sum. And if that happens, this guy is prime. You can't factor it. So it has to fit the requirements, right? Even something like this, you cannot factor down in that trick. Sorry for that. Because you can't square root 7. So even this would be prime. So just make sure that you're checking out the requirements before you try to use the trick. Okay? This guy, is it two terms? 1, 2? Yes. Is it the difference? Yes. So, and can you square root both of them? And the answer to that is yes. Not a GCF, so I don't have to worry about factoring out a GCF. But I have to square root these guys. The square root of x squared is x. The square root of 25 is 5. And then we go plus and minus, and we're done. Okay? Now you try. Look for a GCF first, and then go check your requirements. If it fits, then do the trick. Okay, GCF. What will divide into both of these? It turns out 6 will. 6 will go into 24 4 times. 6 will go into 25 times. Now we look inside here. We've got two terms. It is the difference. I can square root 4, I can square root m squared, and I can square root 25. So, I do that. I make my two parentheses. The square root of 4 is 2. The square root of m squared is m. The square root of 25 is 5. We go plus or minus, and we're done. Okay, check your requirements. It'll make your factoring life much, much easier. Try 5. Stop the video, start it back up, and see if you're right. Okay, two terms, difference, and you can square root both sides. You can square root both terms. So you should have gotten 2x plus 7, 2x minus 7 after you square root these guys. Okay, one more. Check for a GCF, then check for your trick. Okay, so factor out an 8 first. So you get 8 as a GCF. Then you get x squared minus 4, which fits the requirements. Two terms, difference, and you can square root both terms. So we get x plus 2, x minus 2, and we're done. Okay? Hopefully that's easy enough for you. All right, now we're going to get back to our trinomials, and we're, again, going to follow the same steps. Factor out a GCF if you can. Make your parentheses, list the factors of the first term, list the factors of the last term, draw your smiles and see how your factors fit in. Okay? So let's just get to it. Look for a greatest common factor in number 7. There's not one that you can factor out and not have it change anything. So we go right to it. Make your parentheses. Now factor 6. How would you factor 6? You can go 6 and 1, or you can go 3 and 2. Which one do you use? Well, don't know. And so for right now, we know we have two possibilities. So for absolutely no rhyme or reason whatsoever, I'm going to use 6 and 1 and just see if it happens to work. Okay? Now factor down 12. 1 and 12, 2 and 6, 3 and 4. We could do the negative factors, negative 1, negative 12, negative 2, negative 6, negative 3, negative 4, but they're going to have to add to a positive number, and two negatives cannot add to a positive number, so I don't worry about the negatives. All right, when I draw my smiles say that I need to multiply one factor by 6, add the other one, and get 17. So we go through. 6 times 1 is 6, plus 12 is 18, doesn't work. 6 times 12 is already 72, and there's no way we're going to get to 17 from 72, so we can't use that. 6 times 2 is 12. 12 plus 6 is 18, not going to use that. 6 plus 6 is 36, plus 2 is 38, not going to work. So we go 6 times 3 is 18, plus 4 is 22. Now I go 6 times 4 is 24, plus 3 is 27, and none of those work. Since none of those work, then that means we can't use 6 and 1. Now we got to try 3 and 2. Okay, so 3 times 1 is 3. 2 times 12 is 24. That's 27. Too big. Flip them. 2 times 1 is 2. 3 times 12 is 36. 36 plus 2 is 38. Not going to work either. All right. Well, 3 times 2 is, so we're going to try the next one. 3 times 2 is 12. 6 times 2 is 12. Sorry, 3 times 2 is 6. 6 times 2 is 12. 12 plus 6 is 18. Not going to work. So flip-flop them. 2 times 2 is 4. 3 times 6 is 18. You add them, you get 22. Okay, next. 3 times 3 is 9. 4 times 2 is 8. 9 plus 8 is 17. That's the combination that we need. And it took us a while to get there. It's okay. I mean, it's not brain taxing. It takes a few minutes. You just got to keep checking combinations. Well, this is the combination that I need. I need to multiply the 3's together. So the 3's need to go on the other ends of smiles. I got to multiply a 4 and a 2 together. So we get 3x plus 4, 2x plus 3, and then we're done. It's a bit of a process, but it's one that you're just going to have to do and try to find your right combination. Okay? All right. Continuing on, I'll do another one with you here. If you look, there's not a GCF that you can factor out and change anything, so we're not going to worry about it. We just go and make our parentheses. Factor down 4. Well, 4 will go 4 and 1 or 2 and 2. And I'll offer this up as some way to at least pick the factors of the first term that might work out for you. And it's this. If your middle term is kind of small, then most of the time that means you need to break up the factors of your 4 a little more evenly. And so that means to me that I'm going to use 2x and 2x first and just see if it happens to work. That doesn't work all the time. That trick isn't good all the time, but it's a pretty good way to get started. All right, now I'm going to factor negative 35. 35 and negative 1. 1 and negative 35. Negative 7 and 5. 7 and negative 5. Okay? Now you just start checking. Well, 2 times 35 is 70. It's way too big. So I'm not going to be able to use either one of these two. So check these guys. 2 times negative 7 is negative 14. 2 times 5 is 10. Negative 14 plus 10 is negative 4, so not going to work. Check the other ones. 2 times 7 is 14. 2 times negative 5 is negative 10. 14 plus negative 10 is positive 4. This is our combination that we need. So we link our smiles. 2 to the 7, 2 to the negative 5. Turns out it doesn't matter which parentheses you put the 7 and the negative 5 because your leading coefficients are the same, 2 and 2. But there, we're done. Okay? Make some sense? Again, a little bit more thought that you got to put into this. Okay? I'll talk you through one more, and then start letting you do some on your own. Okay? Look for a GCF. No GCF that will make any difference. Now you need your parentheses, and you need your factors of your first term and factors of your last term. Okay? All right. So, this middle number is kind of small, so I'm going to try 3x and 2x first. It just means I'm going to break my factors up more evenly and try them first. I don't know if that works, but we'll give it a shot. And then just start trying. 3 times 7 is 21. 2 times negative 2 is negative 4. That adds to 17. Not going to work. If you flip it around, 2 times 7 is 14. 3 times negative 2 is negative 6. 14 plus negative 6 is 8. Not going to work. Okay, so where were we here? Let's see, did we do these second guys? So 3 times negative 7 is negative 21. 2 times 2 is 4. That's negative 17. Not going to work. 2 times negative 7 is negative 14. 3 times 2 is 6. That's negative 8. Not going to work. And if you look, 2 times 14 is 28. 3 times 14 is 42. And there's no way. Those are just too big. So while, like I said, if the middle term's kind of small, maybe you want to break up your factors. That obviously doesn't work every time because 3 and 2 is not going to work. So now we go back to trying 6 and 1. Okay? 6 times 7 is 42. 42 plus negative 2 is 40. Too big. Turn it around. 6 times negative 2 is negative 12. Negative 12 plus 7 is negative 5. That's the combination that I need. Took a minute to get there. That's what I need. So now my smiles are going to link the numbers I have to multiply together. I got to multiply 6 and negative 2 together. And then the plus 7 comes over here. Okay? And there we go. Okay? Take a couple of seconds. Try 10. Just give it a shot. See if you can come up with the factors of the first term and the last term, and then start trying your combinations. If you get a little frustrated, then start the video and you can see where you needed to go. Okay, so how'd you do so far? No GCF, so you make your parentheses, factor down the first term into 8 and 1, 4 and 2, and those are the ones you're going to try. Factor down the last term into 3 and 1 and negative 3 and negative 1, but we have to add to a negative number, so we're going to have to use the 2 negative factors. Now, negative 10 is not huge, so I'm going to try 4 and 2, and hopefully that works. 4 times negative 3 is negative 12. 2 times negative 1 is negative 2. Negative 12 plus negative 2 is negative 14, and that does not work. So we try 2 times negative 3 is negative 6. 4 times negative 1 is negative 4. That gives us negative 10, and that's it. So at the ends of our smiles, we need to link the 4 and the negative 1, the 2 and the negative 3, and then we have it factored. 4x minus 3, 2x minus 1. Okay? If this is not making sense, you've got to come in during STAR and let me know so we can work through it. Okay? Try this guy. Remember that you're supposed to be looking for a GCF first. Give it a shot. Bring up the video and see if you're right. Okay, have you gotten this far? There's a GCF of 3. So factor out of 3, you get 4x squared minus 3x minus 10. Then you create your parentheses. Factor down the first term, 4 and 1, 2 and 2. Since the middle term is kind of small, I'm going to use 2 and 2 and see if that works. Factor down negative 10 into negative 10 and 1, negative 1 and 10, negative 5 and 2, negative 2 and 5. And then just go to work and try to get, so your smiles, again, if you draw your smiles, tell you that you have to multiply both factors by 2, and then add them together and try to get negative 3. So 2 and 2, that means negative 20 plus 2 is negative 22, no way. And it's not going to work for this negative 1 and 10 either. So 2 times 5 is negative 10. 2 times 2 is 4. It's negative 6. Not going to work. 2 times negative 2 is negative 4. 2 times 5 is 10. That's positive 6 is not going to work. So there again, my little trick kind of backfired. So instead of using 2 and 2, we must need to use 4 and 1 if this is going to factor. So to get negative 3. Well, 4 times 10 is 40. It's going to be too big. So we go 4 times 1 is 4. Negative 10 plus 4 is negative 6. 4 times negative 1 is negative 4. Negative 4 plus 10 is positive 6. Not what we need. 4 times negative 5 is negative 20. Too big. 4 times 2 is 8. 8 plus negative 5 is positive 3. We need negative 3. So we go 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. So that's it. That's our combo that we need right there. So we got to link the 4 and the negative 2. And then the 5 has to go in the other parentheses, and we're done. A little tougher, I will admit. Okay? Hopefully this is making some sense. There's a series of problems for you to try. Try each of these, start the video, and you'll see the answer. And if you're not getting these, come in and see me, and we'll figure it out. Here's the first one. Look for a GCF first, and then try to factor. So you should end up with this when you factor out the GCF. This guy right here, x squared minus 18x plus 131, will not factor. So we're done with that. Okay, try this one. Stop the video, start it back up, and see if you're right. And there you go. Should have factored in the 2x plus 9 and 2x plus 9. Okay? Next one. Should have gotten factor out of 5 first, then you get x minus 3 and x minus 3. And I just remembered something. Let's back up for a second. I realized that I did not factor this out correctly. 2 will go into 162. Well, no, wait a minute, I did. 131. Okay, nope, never mind. I'm okay. Still can't factor that guy, no matter how hard you try. All right, here's 15. Give it a shot. And this one you should get 3 as a GCF. 4z minus 4, and then z plus 3 as your factors. Try 16. You should get 2n plus 5 times 2n plus 5. Okay, here's 17. Should have gotten 4x minus 1 and x plus 6. 18. You should have gotten 4y plus 1 times 4y plus 1. Last but not least, number 19. And again, if you're not getting this, please come in and see me, and I'll try to help make it make sense. This one factors into 3a minus 7b and 3a minus 7b. This one's really tough because of the extra b in there. If you really want to go through it, again, come in and see me, and we'll sit down and go over it. Okay? Homework's out in Canvas. Make sure you get that done by next time.